Welcome you all once again for this 90 days challenge. Chemical reaction and equation. So today in the session we will be discussing about what is meant by chemical reaction and what is meant by chemical equation, and how to do the traditional method for balancing the equation. So we will be discussing all these things in the session today, and different types of chemical reaction we will be discussing on tomorrow's chapter in part 2. So please be stay connect with Spy Acad. Thank you. So a small request for all the viewers, kindly hold your pen and paper or pen and notebook, note it down, and we will be having many things to solve in this session also. Yes, so going forward, what is mean by chemical reaction and what is mean by chemical equation? So what is mean by chemical reaction? So as you know about the chemical reaction, when there is one or more substance will react with each other. So they will be reacting with each other. It will form the new product. It will form a new product called as a substance. It will form the different substance. So from product to substance, the reaction of product will be the reaction of reactant we will be getting as in a product. So for example, A reacts with B. A reacts with B, which will gives C. And A and B are in a reactant. A and B are the reactant, and C is the product. So we know that the chemical reactions will involve between one or more substance. So here I have taken two substance. Substance number one is A and substance number two is B. So when these two reactants react, this will form reactant C, and even it can form D, E based on the complexity of the chemicals. Complexity of the chemicals. So this is called a chemical reaction. Okay. So we will have one live example. For this chemical reaction. Just a second. Yes. The live example which we have discussed in the promo video is regarding curd formation, right? So curd formation. So when milk plus H2O is reacted to form curd, right? So here you can see the two component which will forms the one component. So this is called a chemical reaction. And even you can choose it, hydrogen plus oxygen will give water, H2O. So here you will be having 1 O and 2 H to form the water. So this is called the basic chemical reactions, and this involves in formation of a products. So this is called a chemical reaction. Okay. So then what is mean by chemical equation? So water formation, we have written a chemical equation. What is mean by chemical equation? I hope everyone know about this chemical equation. So I have written that milk is treated with water, right? Milk is treated with water. So chemical reaction is a simple representation factor where everyone will use the standardized chemical formulas. For example, okay, let's take milk and water itself. So I can say milk in English. Someone will say some other language. So here the coordination and understanding of the component will varies. So that's why we have been standardizing using the chemical formulas through chemical equation. This is the simple representation. Okay, you can ask me how you will represent this as a chemical formula. How you will be representing the chemical formula using milk and water example, right? Yes, I will be taking a major component of milk, which is called lactose. So what was the chemical formula of lactose? C C12H22O11 is the lactose formula. So where we will be reacting with H2 was the molecular formula of water. So which will gives, so what will give? So in the conversion of milk to curd, there is a chemical change from lactose to lactic acid. Lactic acid. So whenever you drink milk, so with sugar or without sugar, you will be realizing there will be some sweetness will be there in a milk, right? So when you are treating this milk with some small amount of curd, it will go under the fermentation. So you have a question, what is meant by fermentation? We will be discussing the fermentation in biology classes. So today we can focus only on chemistry alone, right? So this lactose will be converted into lactic acid. Lactic acid. What is this lactic acid? What was the formula? Lactic acid formula. CH3, CH and OH. So COOH. So this is the conversion. So see, you can say that lactose to lactic acid, right? But the molecular representation is very important. That is called chemical equation. The chemical equation is the simple. This is the simple and symbol of representation of chemical formulas. Okay. So I hope you understood about what is meant by chemical reaction and what is meant by chemical equation. So just understand the chemical reaction. It is the reaction between two or more component which will form the product. This reactant will convert it into product. And equations. So this is the symbol of representation. Factors such as, and moreover in equations we can denote that whether this is the forward reaction or reverse reaction, whether it is the liquid in format or solid in format or in gaseous format, right? So these representations will take place in chemical reaction. Okay. So then, sir, chemical reaction has happened. How can I know that whether this chemical reaction takes place or not in the experiments? Okay. So once the chemical reaction happen, there is some changes in characteristic, right? There is a changes in characteristic. These are the characteristics involves in the chemical reaction. I hope everyone following the class, the evaluation of gas, change in color, change in state of substance, and change in temperature and formation of precipitate. Okay, we can see one by one of these examples. The first one is evaluation of gas. What does mean by evaluation of gas though? So evaluation of gas is when two substance, when two molecules or the component reacted with each other. So for example, so you can take one test tube. Okay, so take one test tube, add H2SO4. What is H2SO4? H2SO4 is a sulfuric acid. So H2SO4 is sulfuric acid. When you add sulfuric acid in a test tube, add some Zn. What is Zn? Zn is a, what is Zn? Zinc. So it will form zinc sulfate plus H2. What is H2? Zinc sulfate plus H2. What is that? So here H2 is the gas which will evolve in the reaction. So there is a liberation of a gas. So the gas will liberate outside of the test tube, right? So this is called gas evaluation. And change in color. So what is change in color? So once the reaction starts, from blue to green. What is this blue to green? Again, the copper sulfate plus iron, which will gives iron sulfate plus copper. So before starting the reaction, it will in blue color. Once reaction happens, it will change in green color. So during chemical reaction, what you can observe? You can observe evaluation of gases there, change in color, and change in substance of state. What is the state of substance or substance of state? So take a wax candle. So burn it. What will happen? What you will observe? So you can observe that candle wax substance change into liquid. Solid substance changes into liquid, and what gas will evolve in that? Carbon dioxide, right? So you can see here within this reaction, you can see wax, it is in solid converted into wax liquid, and it is converted into carbon dioxide as a gas. So this was the good example for change in state of substance and change in temperature. So in other words, we will be saying that exothermic, so which it means evaluation of heat. So you can take same zinc plus sulfuric acid, which will form zinc sulfate and H2 hydrogen. So you can see that here the temperature change will be happen. Okay, you can see that the temperature will change. It will produce heat in that, and formation of precipitate. So formation of precipitate, you can see the after completing the reaction, you can see some small sand like appendages will be there in the test tube. It is called precipitate. So it is commonly happen in barium chloride plus sodium sulfate. When you treating this two, it will form what it will form? It will form barium sulfate and sodium chloride, right? In this reaction, you can observe the precipitation of particles. So this is called formation of precipitate. Okay, so these are the chemical reaction. These are the chemical reaction characterized, right? Once the chemical reaction happens, once the chemical reaction completes, these are the characteristics you can see. Any one of the character. I didn't mean that all character will be there. You can see any one of the character during the chemical reaction. Okay, I hope everyone understood about chemical reaction, right? So going up with chemical equation, excuse me, chemical equation. So one is balanced chemical equation. What does mean by balanced? What does mean by unbalanced? So we have seen two things are there. One is reactant, and another one is product. So both the side it should be equal. If it is unequal, we need to do the balancing of reaction or equation. Sorry, it is equation. Balancing of equation. Okay, so law of conservation of mass. So mass can either be created nor be destroyed in chemical reaction. We could not create or it cannot destroy the chemical reaction. It will be same. The ratios will be same, right? So that is the total mass of element present in the product of chemical reaction has to equal to the total mass of the element present in the reactant, right? So in other words, the number of atoms of each element which remains same before and after the chemical reaction. So it should be same. Hence, we need to be balance a skeletal chemical equation. So we need to balance the skeletal equation. Remember in that you can only change the coefficient of the molecule. Only we can change the coefficient of the molecule. You could not change any other chemical formulas. You could not change any chemical formulas in balancing the chemical equations. Chemical equations. Let I add some examples to show you up how we can do the chemical equations, balancing the equations, right? Fine. Yes. So here you can see S8O2 gives SO2. S8 sulfur plus oxygen gives sulfur dioxide. So you can observe one thing, just a second. 2H2 plus O2 gives 2 half H2O. We can solve one by one. This was the second example. Just we can solve first one. So you can write the chemical molecule separately. So S equal to 8. So reactant side and product side, right? So you can write reactant side and product side separately. So what you can see, so in reactant left hand side you can see 8 sulfur is there, here only 1 is there, right? Which is not equal, and in oxygen you can see both are equal. Now I need to do the equalization. So already I have informed you can change only the coefficient, not any other thing. So coefficient means, so before this element you can write any numbers to match it. So in left and right hand side you can see I have only 1 sulfur. So what I will do, I will write 8. So into 8. So now both the sides are matched, but oxygen you can see here 8 into 2, it is 16. So now in right hand side it is 16. Now it is 16, but left hand side you can see only 2 oxygen is there. So I will be replacing with 8. So it will change it to 16. Now it is balanced, right? So now you can write it up. S8 plus 8 of O2 gives 8 of SO2. Now you can see everything is balanced here. Everything is well balanced. And going up with the next one. So you can see here how many H's here. So you have HO in left hand side and again HO in right hand side. So you have 4 and you have 2. So in right hand side also you can see here it is 4 and it is 2. So this equation is already in balanced state. So you need not to balance anything, right? Fine. Now the third example, Fe. So first write it. This is reactant side. This is product side. So one is reactant and another one is product. So take this reactant molecules, write it down, FeHO. Again in reactant product side, FeH and O. So how many Fe is there? Only 1. How many H is there? In reactant side it is 2. How many oxygen is there? Only 1. Right? So here how many Fe is there? It is 3. And how many H is here? It is 8. And how many O's there? It is 4. So you can see iron Fe in reactant side it is 1, in product side it is 3. So what I can do, I will be replacing the coefficient into 3. Now 1 into 3 equal to 3. So it is done. Again in H, so in reactant side it is 2, in product side it is 8. So what I will do, into 4, which is 8. So I will replacing it 4. Right? And if I'm replacing 4 here, oxygen will also become 1 into 4 equal to 4. Now, so everything is balanced, right? So iron is balanced and hydrogen is also balanced. Oxygen is also balanced. So now this is the balanced equation. So after balancing, 3Fe plus 4 of H2O, which will gives Fe3 O4 plus 4 of H2, right? Coming up with next example, and this is the last example also. So now you have CH4, Cl2, CCl4 and HCl. Okay, how many components I have? C is there, H is there and Cl is there, right, in reactant side. So in reactant side and in product side again C is there, H is there and Cl is there. Fine. So how many C is there? How many carbon? It is 1 carbon. Here how many carbon is there? Again 1 carbon. How many H is there? It is 4. Here how many H is there? Here only 1 H is here. And Cl, how many Cl is there? 2 Cl is there. Here how many Cl? Here 4 Cl and here 1 Cl. It is 5 Cl. Clear? I hope everyone understand about this divisions, right? So you can see here 1C is here, I have written 1C and 4 H is there and I have written a 4H and Cl2 is there and I have written a 2Cl. Here you can see 1C, 1H and Cl4. Here 1 Cl is there, then 5 Cl. So I have written it. Now 1C, 1C which is matched, which is balanced, and 4 H is here, only 1 H is here. Then what I need to do? I need to write 4 here. If I write 4 here, then what will happen? My Cl will increase. So here 4 H is here, here only 1 H, so 4 Cl. So 4 plus 4, it is 8 Cl now. Again, here it is converted into 4, but Cl is 8. So what I am going to do, I will be mentioning here 4. Then I can get 8 Cl. Now everything is balanced, right? So CH4 plus 4 Cl2, which gives CCl4 plus 4 HCl, 4 HCl. So you can count it down. So 4 Cl, again 4 Cl, that is 8 Cl, 4 H is there, 4 H is here, and 1 C is here, 1 C is here. Everything is balanced, right? So this is the process of balancing the equation. I hope everyone understood about this balancing equation. So we can summarize the thing what we have learned. So we have learned about the chemical reaction and equation. So chemical reactions and equation, I hope you have noted down the definitions for chemical reaction and equation with examples, and we have discussed about characteristics of chemical reactions what are the characteristics will happen when the chemical reaction involve in the uh, process, and we have discussed about the balanced chemical equation. What is meant by balancing the chemical equation? We have seen different examples in today's class. So if you have any doubt or any concern, feel free to connect with us. You can mention the comment in your chat box. We will be addressing your doubts and queries. So thank you for today's session.